just like example 2, we take the question, and it says calculate the sum of this geometric series. So I want the sum. I write out my formula. Sn equals term 1 minus r to the n over 1 minus r. So I've got my formula. And I want to find the sum. So I want to find this. So off to the side, I have to ask myself, do I know term 1? Absolutely. Term 1 is -3. Do I know r? Well, no, but yes. R is going to be 5. Sometimes you can see it. Can you see it going from -3 to -15 is multiplying? Sometimes you can't, and if you can't, you can just take any 2 in a row and divide them. And if I took -15 and divided by -3, I would get +5 that way as well. So it's good to see that you can always take 2 in a row and divide them. And the other thing I need is n. Uh-oh. I don't know n. So I plug everything into I look at the formula, I look at everything I need, and there's something I don't know. So this is telling me I need to find the n first, which may mean well, in this case, it means that I have to go to another formula. It's geometric. The other formula that I have is this one. And now I would want to find n. I already know term 1 and r. Do I know the last term? I do. So I can use this formula because I know that whatever n is, that last term is -4, 6, 8, 7, 5. I know my term 1 is -3. I know my r is 5, the n minus 1. And now I have an equation where I can solve for n. And these ones are a little bit tricky because we have to do a little bit of guessing and checking. I'm going to get my term with the n, my power all by itself, by dividing both sides by -3. So that's going to give me 15,625. And n has to be a nice number because we're talking about sequences and terms. They have to be whole numbers. It has to be a positive whole number. So what I'm going to do is I'm going to go to my calculator and just start looking for 15,625 as a power of 5. So I'm going to try 5 to the, what do you think would be a good guess to start? 5 to the 6. Oh, you got it right away. Sometimes that happens. If it was too small, you try a bigger number. What that means for us is we can rewrite this left as 5 to the 6. It's supposed to equal 5 to the n minus 1. I wonder if n minus 1 is here and 6 is here. I wonder what n is. It has to be 7. And now I just figured this. I figured out the last piece of information for my other formula. I needed to know that there was 7 terms. Once we found 7, so I need to find n first. Now I can find the sum. So my sum of my first 7 terms, now that I know n is 7, is equal to term 1 we figured out was -3. 1 minus r was 5 to the n 7 over 1 minus 5. If you have a graphing calculator, again, I'd suggest try typing this in all at once. Bracket, -3, bracket, bracket, 1 minus 5 to the 7. Close that bracket over 1 minus 5. If you don't have a graphing calculator, then do your order of operations, do little bit by little bit. Always check your answer, -58,593. Yep. So circle question number 9.